Okay, this is problem 314, and we're looking at a company called Travis Metals, which I guess fabricates copper wire by shaping it from copper ingots that they heat in a large oven. So we have some data here, 10 months worth of data showing the number of ingots processed and the power cost associated with that processing. So what the question asks us to do is to basically understand the cost behavior and then use that understanding to predict the cost of processing a certain number of ingots. Okay, so the first part of the question down here, using Excel, prepare a scatter graph by plotting ingots processed and power costs on a graph. Okay, so let's do that first. Of course, in an exam, I could not ask you to do this because we unfortunately don't have access to Excel in an exam. However, I thought it would be useful to show you how to do this anyway. So in order to create a graph in Excel, they're actually called charts. So the first thing you do is you highlight the data, as I've just done, and then you insert a chart. You see it up here in the top column. And then it asks you, which type of chart do you want? Well, we want a scatter graph, so we're going to choose XY scatter about halfway down. And we just want the dots on the graph, a plain scatter graph. So there it is. I'm just going to move it down into place over here, and then we'll come down and work with it. Okay, so within this chart, which is now highlighted, and you can see that chart up here in the top menu bar is highlighted in dark green. And so we can look at the elements. I'm just going to get rid of that chart title. We don't need it. I'm going to get rid of the series 1 at the, series 1 at the bottom. Let me go back to chart, elements. I'm just going to get rid of that legend. We don't need it. Okay, so there we are. Now, the x-axis along the bottom, that's the number ingots processed. And then along the y-axis here, that is the power costs. Now this is the cost, the power costs, that we will try to forecast later in the question. Okay, so looking at the graph, I mean, it looks to me like there's a linear relationship there. It looks like there's a straight line that could kind of go through there and touch or be very close to most of the dots. So the question then asks us to use the add trend line feature in Excel to plot a line through the points on the graph. So this is like a statistical technique that Excel is going to use. I'm going to highlight that graph again. I'm going to highlight chart, and there are my elements. This time I want to add a trend line, and this is going to give me basically a line of best fit, which you may remember from your stats class or high school math. And there's that line of best fit, and that convinces me, do power costs appear to be related to the number of ingots processed in a month? I would say yes, they do appear to be related. Yes, appears to be a linear relationship. I mean, it's not perfect. It's not perfectly linear because not every dot touches the line, but they're all pretty darn close. If I just extended this trend line, okay, I would expect a y-intercept not through the origin. So that sort of tells me that this part here is like the fixed component of the cost, and up here is the variable component, because no matter how many ingots you produce, there seems to be a fixed cost there because the x-intercept is somewhere just below 1,000. And then after that, the cost behavior is variable because it increases as the number of ingots processed increases. There appears to be a linear relationship, and cost has fixed and variable components. And this is, of course, the power cost. Okay, next part of the question. Using the high-low method, estimate a cost formula for power costs. Okay, so first, on an exam, I could ask you to give me this kind of narrative, just describing the relationship that you're seeing. I could also ask you to do the high-low method, so let's practice doing that. What I do in the high-low method is I look for the highest data point I have and the lowest data point. Well, just scanning through my ingots and my costs, May looks like my high. I have 130 ingots at a cost of 6,000, highest on both counts. And scanning through for the low, October looks to be the low. So those are the two items that I need, May and October, my high and my low. So I actually have already included this data. I'm just going to show it now in black font. So we've got our high and our low. We've identified them, and we've got the two data points, the number of ingots processed and the power cost. And now the question is asking us to express the formula, the cost formula, in the form of y equals a plus bx, which is sort of equivalent, if you remember from high school math, to the formula of a line, y equals mx plus b, where m is the slope. Whoops. Okay, that's not what I wanted to do. Okay, m is the slope. And b is the y-intercept. Now, in this formula they use here, y equals a plus bx, the b is actually the slope and the a is the y-intercept. Okay, so if you remember from high school math, in order to get the slope, what you want to do is take the change in y over the change in x. That's how we get the slope, right? So I have done that here. The change in y, which is the power cost, and the change in x, which is the ingots. Let's just go back here. Turn those things black. Change in the number of ingots is 90. To get from 40 to 130, that's a change of 90. And the cost also increases when you go from the low to the high by $3,600. So our slope, delta y over delta x, equals $3,600 over 90 ingots processed. And that is $40 per ingot processed. Putting that into the cost formula, y equals a plus 40x. So again, thinking back to your math class, in order to solve for a, we need to take one of these 2 points and just insert it into the formula. So let's just take the low for October. Our y value is $2,400. $2,400 equals a plus $40 per ingot processed. Essentially, that's what the 40 is, times x, which is 40 ingots. This 40. 2,400 equals a plus 40 times 40 is 1,600. Solving for a, it's going to be 2,400 minus 1,600, which is 800. So my formula is Y equals $800 plus 40x. Now let's just change that into our cost variable terms. Y, so power cost, equals $800 plus 40 times number ingots processed. Okay, again, this is my fixed component. This is my variable component. Varies based on the number of ingots processed. Okay, so that's my formula, my cost formula. Let's go to the last part. Predict total power costs in a month when 140 ingots are processed. Okay, well, I'm going to use my formula. Power cost, I expect, will equal $800 plus 40 times 140 ingots processed equals $800 plus 40 times 140 is $5,600, which is adding those two together, $6,400. So if they produce process 140 ingots in a month, I expect that the associated power costs are going to be $6,400. And that's it.